Okay, so perfect square trinomial cases. All right, let's take a look and see what we got here. So we've got a plus b squared. What that is you could rewrite that as a plus b times a plus b, and that's going to give you a squared plus 2ab plus b squared. Just to show you that's what you get, let's do it ourselves. So this would be a squared. This would be plus ab plus ab plus b squared. You got two of these here, so this would be a squared plus 2ab plus b squared, which is what that was right there. And if we look at the kind of the opposite case, it's a minus b squared, and they're going to say that a minus b times a minus b is going to give you a squared minus 2ab plus b squared. Kind of like a tongue twister. So let's go ahead and prove that. I'll distribute. I get a squared. This is minus ab plus b squared. And then you got two of these, so it would be a squared minus 2ab plus b squared, which is what this is right here. So why does that matter? Well, it can help us determine whether or not we have a perfect square trinomial. So if you see this ahead of time, it might be able to save you some time, essentially what it comes down to. So it says determine whether if each one is a perfect square trinomial. So what we're going to do is our first step, we're going to check, is the first term a perfect square? Is the first term a perfect square? So is 4y squared a perfect square? It is. You could rewrite 4y squared as 2y squared. So yes, it is. Second one you're going to look at is, let's put it right here, is the last term a perfect square? I'll have to excuse my handwriting. Is the last term a perfect square? Well, what's the last term? The last one's 9. Sure is. You could rewrite 9 as 3 squared. So yes, it is. And then your last question is going to be, is the middle term equal, is it equal to, notice how we have pluses in here. So we're going to be taking a look at this one right here. Notice how this middle term has a 2ab. Well, then this should be equal to 2 times your first term and your second term. So this is like your a, this is like your b. So this would be 2y and 3. So is this equal to 12y? Well, let's find out. 2 times 2 is 4, and 4 times 3 is 12, so that would be 12y. So is 12y 12y? Sure is, so yes. So yes. So yes, this is a perfect square trinomial. Awesome. All right, let's check the last one. So one, I won't write everything out, but same thing. Is the first one a perfect square? 9x squared. Yes, it is. I could rewrite that as 3x. So yes. 2, is the last term a perfect square? Sure is. 4 would be 2. That is a perfect square. Is the middle term, And now you have the minus in here, so you want to check this one over here. So minus 2. So is the middle term equal to negative 2? And then I'm going to fill these in, 3x and 2. Is that equal to negative 6x? Well, 2 times 3 is negative 6. Negative 6 times 2 is negative 12. So no. I'll put that means no. So no. So then not a perfect square trinomial. Let me draw a little frowny because it's not. Okay. We got 3 more. We're almost there. We're actually going to skip B, so you can cross B out. We are going to do this one. It says factor each if possible. If you cannot be factored, write prime. So what we want to do first is we have a GCF of greatest common factor of 5 that we can take out. So let's take out the 5, and what we're left with is x squared. If you take out 5 from 80, 80 divided by 5 gives you a negative 16. Oh, and then look, here now we have a perfect square. So we can, or a difference of squares, sorry. So now we can let's rewrite this as x squared minus 4 squared. And then 5x, this will be x minus 4, and x plus 4. Yeah, you can skip this middle step. So you can skip this middle step if you want. I just like to write it out so you guys see where it's coming from. So we factored it. It doesn't say to find the roots, so I'm just going to say that we're done. We're good there. We're going to skip B. And then there's one more thing I want to show you guys with square. It's called a square root property. And what we have here is we have y minus 6 squared is equal to 81. Well, we could actually take the square root of both sides and figure out what y is. So what I'm going to do is I'm going to take the square root of this side, and I'm going to take the square root of this side. And just to give you guys a quick example, let's say that we had 5 squared. Well, we know that 5 squared is 25, right? But what if you take the square root of 5 squared? Well, it's 5 squared. Well, 5 squared is 25. And what's the square root of 25? Oh, well, that's just 5. So what do? They essentially cancel each other out. So these are going to cancel each other out, and we're just going to be left with y minus 6 is equal to the square root of 81. And what's the square root of 81? Well, that is 9. And now it's nice and easy. I can just solve for it. Add 6, add 6. So y is equal to 15. Let's try the same thing over here. I'll take the square root of both sides. I'll be left with x plus 6 is equal to the square root of 12. I'll subtract 6. This isn't going to turn into anything nice. I just punched this into my calculator and I got that x was around negative 2.54. And that's it. Oops. There you go. All right. That's it. And then you guys will have your little knowledge quiz, knowledge check, and then you'll be good for the week. If you guys need help, let me know, and I will talk to you guys later. Bye.